You are the first caller and will be placed on hold until the next caller arrives.
Good morning, folks. It's Naveen joining the call, and I think we can go ahead and get started here. So welcome again to kerneltraining.com, guys. So we're a group of individuals who have started the kernel training, and we are experts in the areas of the big data and the data science platforms. So feel free to go ahead and stop me if you have any questions. So what my plan is going to be for today is today I will give you a brief introduction about myself in a few minutes, and then we'll talk about what is big data and what is Hadoop. The aspects that we will talk about will be, let's say, go ahead and put what is big data in Hadoop and why it is important and how it is used in real world. Then we'll go ahead and have a look at the content for this course, Big Data and Hadoop, and we'll also discuss about the final projects or some of the projects that we will be doing as part of our course, guys. Okay, so that is going to be the plan for today. So let me go ahead and just introduce myself here. So my name is Naveen, guys, and I have about 18 years experience totally in IT. 10 years, over 10 years I lived in US, and the past 7 to 8 years I'm here in India. Last 2 to 3 years I'm heavily involved in the big data and data science platforms and technologies, guys. Okay, so that's a brief introduction about myself, and so let's move on here. Before we move on to big data, let me go ahead and come back here. Let me go ahead, kernelsphere.com. So this is our website. This is the company. Oops, my bad. And here is our kernel training website. Just in case you need any additional information, things like that, you can come to either of these websites and try to log in here. And once you register, you should be able to get in most of the details. So we're offering different courses. You can go ahead and log in here, and then we're also working on some other aspects of the website. For now, just have a reference of this. If you need to just get in touch with us, have this as a reference, guys. Okay, so having said that, the next thing I want to do is I want you to look at our content real quick, what we have here. And let me go here, close that. Pardon me. Okay, so here is our course content, gentlemen. It's going to be a 6-week course. Each week we are looking at about 6 hours, so that adds up to 36 hours. And week 1 we will focus on what is big data and Hadoop introduction in module 2 we will try to understand the Hadoop cluster architecture and get into the MapReduce concepts. Then in module 3, in a minute I will show you the details of each of these sections, guys, but this is a quick overview. Okay, in module 3 we will get into much more advanced concepts, and in week 2, which is about the module 3 and module 4, we're looking at the advanced MapReduce concepts, and we'll talk about how to design a cluster, and we'll touch on the aspects of Hadoop 2.0. By this time we would have covered Hadoop 1.0, how it works and things like that. So we'll move on with Hadoop 2.0 and Yarn and try to understand what are the differences and things like that, guys. Okay, so in week 3 Pardon me, sorry about that, guys. In week 3, module 5 will cover about pig and a hive, and then in week 4 we'll cover about Hbase and scoop, and in week 5 we'll cover Flume Uzi and a final project in the banking domain, guys. We're going to have a look at this in a minute or two, but in actually a few minutes. And then today, Spark is one of those projects which is receiving some good attention, guys, okay? So we have added some of the aspects of Spark, so we'll cover the fundamentals of scale and the introduction of Spark, and we'll try to get into some of the details of Spark and try to understand about Spark, guys, okay? It's a whole new course by itself, but for today we will just go ahead and focus what are the we'll try to understand it from a slightly high level, and in this module we'll go a little bit deep and try to understand how it works, guys, okay? And looking at a bit more detail, here is module 1, guys. Pardon me. So in big data, these are the things that we will be covering. So what is big data, the challenges, the traditional architecture, the traditional approach of versus the Hadoop way of doing the things. What is the difference between traditional architecture and Hadoop's architecture? What's a distributed model? What's a distributed file system? How does it work? What are the different aspects of big data in Hadoop? You know, like replication, fault tolerance. And why Hadoop from a perspective of business and technical perspective. We'll also try to look at that, and we'll also discuss about some of the ecosystems projects, the projects which form the ecosystem of Hadoop, guys, okay? Then we'll briefly discuss about some of the use cases of Hadoop and some of the fundamental design principles of Hadoop, and we'll compare Hadoop versus the relational database and try to understand what are the main differences. That is going to be the module 1, guys, okay? Coming to module 2, we'll try to understand the cluster architecture. What is the different components from a high level, and what is the workflow of Hadoop? What happens when you read the files, when you write the files, when you load the files, and things like that. And then we'll get into the MapReduce introduction. In MapReduce, we'll try to understand, you know, what are the different aspects of MapReduce, and we'll look at, you know, we'll try to understand one of the basic problems of the Hello World version of the MapReduce. We'll start with a slightly simpler example and move on to slightly a complex example. Then we'll discuss a bit more deep into the mapping, reducing, and shuffling in this module, guys, okay? And then in module 3, as we continue, and I think this is going to be in week 2, we'll look at some of the advanced aspects of MapReduce, like working with combiner, partitioners, counters, the different kinds of input formats. This session is going to be slightly Java oriented, guys. If you're not much into Java, probably you can just hang in there and kind of try to see how things work internally in Java and understand the complexity of the things when we do in Java, guys, okay? Once you understand the complexity, you will be able to appreciate how easy and simple it is that we can do this kind of things with only a few lines of code using the other projects such as Pig and Hive, guys, okay? So if you're much into Java, then this is purely for you folks, okay? We'll try to understand in the next module the configuration aspects of the Hadoop. You know, Hadoop is a distributed file system where you have lots of nodes and servers. They communicate with each other. How do they communicate and things like that? From a configuration perspective, we'll cover these things. And in Yarn, then we'll come to the Yarn. So in here we'll be discussing, up to here we'll be discussing Hadoop version 1.0, then we'll move on to Hadoop 2.0, and we'll discuss the different aspects of 2.0, guys, okay? And here is Pig. I will probably not read out everything that is listed here, guys, but we'll also look at some advanced exercises in Pig, which will be pretty useful for you guys. And in the final project also, it will give you some advanced perspectives of Pig, how the things are done, guys, okay? Coming to Hive, they will start from the fundamentals, architecture, and we'll look at manage tables, like partition tables and buckets and partitioning, static partitioning, dynamic partitioning, and so on, guys. Okay, and then we'll move on to Hbase. We'll start with CAP theorem and try to understand what is NoSQL and things like that, how it is applicable, how it is used, how the columnar-oriented databases are different from row-oriented database and things like that. And then we'll move on to Scoop. We'll try to understand how to transfer the data from HDFS into a database and vice versa. And we'll look at import, export, and there are a few scenarios called incremental append. We'll also try to understand that one. Then in the week 5, we'll look at Flume and Uzi, guys. So we'll also try to do a project in Flume where we will go ahead and download some of the tweets from Twitter, and then we'll write a few scripts in Hive to analyze, to understand how things work in Flume. And then comes the final project in banking domain. I'm going to be talking about this towards the end of our session today, guys. So just give me a few minutes there. We'll try to understand the problem definition, what is the solution we come up with, and we'll also try to discuss about the different data sets and the specifications of this project, folks. Okay. Finally, we'll discuss about fundamental aspects of Scala and Spark, and we'll try to understand how it differs from Hadoop and what is Storm and how that differs from Hadoop and things like that. Get a feel of Spark here. That is going to be the final session, guys. Okay. So coming back here, if you guys are okay, we can move on to the discussion part today. And we'll, as I indicated, we'll start with what is big data. Just give me 1 second here, folks. Okay. All right, gentlemen, ladies, we'll go ahead and get started. We'll first try to understand what is big data, guys. Okay, so let me bring up my tool here. All right, guys, so I'm going to go here. I'm going to do a snap of that. So, gentlemen, ladies, here is what is going on, guys. What's going on today is, if some of us were to go ahead and digitize all the data that we have been collecting right from the beginning of the time till 2003. It's supposed to be about 5 exabytes, guys, okay? You already may have an idea that 1 terabyte equals to 1000 gigabytes, okay? You may have an idea, may or may not, 1 petabyte equals to 1000 terabytes, guys. And then comes 1 exabyte, which equals to 1000 petabytes, and then comes 1 zettabyte, which equals to 1000 exabytes, guys. So this is what is going on, all right? So right from the beginning of the time till 2003, if we would have digitized the data, it would have been about 5 exabytes of data. So what is happening today? Let's go back here. Okay, in the year 2012, what happened is there's about 2.7 zettabytes of data which got generated, guys. Okay, so come back here. Pardon me, sorry about that. So come back here, all right? So in the year 2012, that's about 2.7 zettabytes of data. That is about 500 times more amounts of data which got generated than what got generated in the entire time span from the beginning of mankind, since when we have started generating data up to 2003, guys. Or in other words, what we mean is, what happened in 2012, ladies and gentlemen, every 2 days we have started generating the amount of data that the entire mankind has generated up to 2003. That is the amount of data that we have generated up to 2003, and every 2 days we have started generating that amount of data. In the complete year, that ends up being 2.7 zettabytes, guys. Okay, at a fundamental level, what we are looking at, okay, guys, is this one. Let's say if this dot, if this period is the amount of data that we have generated up to 2003, okay, what happened is in 2012 we have generated that amount of data. Just in a year, in 1 year we have generated that amount of data, guys. Okay, I repeat, up to 2003, if that is the amount of data that we have generated. In 2012, this is the amount of data that we have generated, guys. Okay, so if you compare this one with this one, what is happening is every 2 days we have started generating that amount of data beginning of 2012. Why? We will see that in 1 minute, guys. Okay, so let me go back here. So now we're trying to understand why we have generated so much of data. Where is this data? What is the data that we are talking about, guys? Okay, there are two kinds of data, guys. Okay, one is user generated data and another one is machine generated data. Okay, user generated data is something that you enter in your Facebook, Twitter, LinkedIn, and so on, guys. Okay, machine generated data. As we are accessing any of these websites, what is happening is there are a lot of log files which are getting generated. Apart from that, if you take any of the binary generated data, let's say you go onto the street and there are CC cameras and things like that, right? Today, almost every city and town, for security reasons, they go ahead and put up these CC cameras and things like that. They are also doing a lot of recording of the video. They're taking images and things like that. This is the example of the machine generated data or the binary data, guys. Okay, and what else we have? Well, we have different kinds of sites, guys. We have YouTube, we have Facebook, we have Twitter, we have LinkedIn, and different kinds of sites. What are these things doing? Well, they're also generating lots of data. What is this one? When we are saying we have generated the amount of data that the entire mankind has taken, we're generating every 2 days that the entire mankind has generated up to 2003. What is the data? These are the different kinds of data, guys. Okay, so that's where go ahead, take a snap of that. So those are the CC cameras, and that is, maybe you can think of a YouTube, maybe the Facebook, Twitter, Flickr, and different kinds of data, guys. Okay, so some of the things to keep in mind. What are some of the things to keep in mind, guys? Well, here are some of the things to keep in mind, guys. At a fundamental level, what we are looking at is the volume of data, guys. Okay, when we say this is the data that the entire mankind has generated up to 2003, and just in 2012, that is the amount of data that we have generated. What are we looking at? At a fundamental level, what we are looking at is the volume of the data. The volume of the data growing from this size to this size means it is not double, it is not triple, 10 times or 100 times, guys. It is an exponential volume of data that is getting generated is what is happening. Okay, so at a fundamental level, it is volume, guys. Okay, and then we have seen, if this is the time span from 0 to 2012, and this was the time at which we have started recording the data, and this is 2003, and somewhere here is 2012, right? What is happening? In just 2 days, we are generating the entire data again that the mankind has generated, this one. Okay, so what are we looking at? Well, another fundamental aspect that we are looking at is the velocity, guys. Okay, the rate, the speed at which we are generating the data is again not double, not triple, not 10 times or 100 times, but it's exponentially huge, guys. Okay, and then, gentlemen and ladies, we have just seen that there's a lot of sites which are generating a lot of data. What does that mean? Well, what that means is, that's another aspect, guys. What is that? That's variety of the data. What is the variety of the data? Well, variety of the data means if you take Twitter, they expose their data in the form of JSON. If you take Facebook, they expose the data in the form of XML. You have YouTube, you have lots of images and different kinds of binary files, right? So what is happening? Well, there's different variety of the data. What do these three things refer to? Well, these three things refer to the big data, guys. Okay, these three things together are creating some big problems. What is that? Well, they are the big data. So at any point of time, if you get a question, what is big data? Big data refers to three B's, guys, okay? That's the short answer. Why? Again, remember, the exponential volume of the data and the rate at which everybody today likes to get onto Facebook, Twitter, and things like that. Why? They're simple to use, they're easy to use, and people like to share. They like to share something good, something bad, and so on, guys, okay? So what is happening? The speed at which these sites are generating the data is increasing, and they're all generating different varieties. One is exposing the data in JSON, XML, and so on. So that is what the variety refers to, guys, okay? So that is the that is about the big data, guys, okay? We'll also try to see why, there's a lot of volume of data, a lot of velocity of data, a lot of variety of data. Why should we care about it? We will try to understand that one in a few minutes, guys, okay? So fundamentally, that is what the big data is about there. It's about a lot of data getting generated in short periods of time is what it is, okay? And here is some more examples of big data. What you have, well, this is the example of structured data, the data which is in a database, guys. Inside a database, whatever data you have, let's say you have a table, guys, what will happen is you generally tend to have some schema associated with it. What is the schema? Well, the schema refers to something like, the parents, the child, the relationship, the constraints, and things like that. So if you happen to write a .NET or a Java program, what will happen is the schema and you're writing a program on that. That kind of data is referred as the structured data, guys, okay? Semi-structured data. If you take XML, if you take JSON objects and these kinds of objects, they have some kind of structure associated with them. It is not complete. It will not tell us everything about the data, but there is some structure, high-level structure. That is why they refer to as the semi-structured data, guys. Then you have unstructured data, guys, okay? Most of the log files, if you take, they don't have any structure or any kind of they're just plain files, and they do not have any structure associated with them. That is called the unstructured data, guys, okay? So we have ideally two kinds of data. One is structured data and one is unstructured data. Semi-structured data is also part of the unstructured data, guys, okay? So now we'll try to understand, if there's a lot of data and lots of speed of data is coming in, why it is important and things like that, okay? We'll try to we'll try to look at an example. So let's take, so here is what happened, guys, okay? Let me go back here. One day, the company Samsung went ahead and released a cell phone, Note 3, okay? The Galaxy Note 3, okay? After a few days, 1 or 2 days later, people started talking about it on Facebook. People started tweeting about it on Twitter, and there are other social networking sites where people started talking about it, okay? What happened? One of the guys, okay, what he did was when he goes ahead and he was casually interacting with his friends, he got excited and he said, hey guys, I bought this Note 3 and I'm really in love with it. I'm really liking it, I'm loving it, and I'm doing lots of stuff and things like that is what he posts on the first day, okay? On the second day, another friend of his also is in the same situation where he's also looking around for purchasing a phone. So what happens? Well, he comes across this post and then he goes ahead and he writes to him, and he just responds to him. Would you like me to? Would you recommend me to purchase? Okay, response, and he tries to get his recommendation. Okay, and 1 or 2 days later, the first guy comes back, and what does he say? Well, he finds there's a problem in that, and he says no. Okay, what happens? Then he says, there's some problem in the video. So if you're purchasing, just take care, make sure that it's working. Otherwise, I would not purchase. I would wait for some more time and things like that. What is happening? Well, these guys are casually interacting, guys. But behind the scenes, what is happening is there are a lot of companies, third-party companies and things like that, who are detecting these conversations, guys, okay? They're trying to find out who are liking it, who are loving it, and are they recommending it, are they not recommending it, and things like that. That is called sentimental analysis, guys. Okay, so companies like Samsung, what they will do is on internet they will try to browse every conversation where their keywords such as Samsung, Note 3, Note 4, Note 5, all these things are appearing. Then what will they do? Well, they'll try to understand, are the people happy or are the people not happy about it? Okay, if they are not happy about it, what will they do? Well, they will try to understand their problem. They will try to understand the root cause. Okay, so what did Samsung do in this case? Well, here's what Samsung did, guys. The moment they identified one of the guys is not recommending, they analyzed it and they understood that this guy is complaining about the video. So what did they do? Well, they contacted the design department in US and they said, please verify this scenario. Is this happening only in one phone, or is this a scenario which is happening in all the phones? Then what did they do? They immediately went ahead and contacted their manufacturing department, guys, in China. Okay, manufacturing department in China, and then they said, hold off, don't manufacture any more cell phones because we are reviewing a particular scenario and we do not want to we would not like to manufacture a lot of defective cell phones. So what is happening here? Well, what's happening is companies like Samsung, they don't really need to wait until the customers come back to them and about their problems. They are proactively going ahead and trying to figure out what their problems are. And as they figure out the problems, what are they doing? They're taking actions, guys. The way they're reaching out their other departments and holding off. Okay, what will happen? Well, if they would not have contacted their manufacturing department by now, and they would not have said, what will happen? Well, China will manufacture about 1 million cell phones on a daily basis. What does that mean? Well, China would be manufacturing millions and millions of defective cell phones, guys. Okay, if a problem like if a solution like this did not exist, where did not exist, what would happen is a customer would go ahead and get back to the service center and say, hey, looks like I have a problem in the video, please return my money, and things like that. What will happen? By the service center will then try to escalate. We'll try to open a ticket and send the ticket back to the design department in US, and then the design department will then try to open a ticket and send another ticket to the manufacturer. What will happen? About a week or 2 weeks. And then the problem is the manufacturing department in China by then would have manufactured about millions of cell phones, guys. Okay, so what is happening is they are proactively detecting what their problems could be, what the problems the customers are having, and things like that, guys. Okay, so that is what is called going from reactive mode to predictive mode. Okay, ladies and gentlemen, if you take this concept, guys, okay, it is not just pardon me, sorry about that, guys. This is a concept which is not just applicable just to the Samsung department or Samsung company in US, guys. Okay, Samsung can use the same concept across all their products, whether it's a video, whether it's a TV, or whether it's another kind of thing. What will happen? Well, they have an easy way. They are proactively detecting their problems. They are not waiting for the problems to occur. They are going ahead and predicting. They're trying to detect what the problems could be, and they're proactively taking care of those problems, guys. Okay, I hope that is making sense, guys. So that is about the insights and the knowledge that we are referring to. And one more thing, guys. Okay, if you take Samsung, this concept is not just applicable for Samsung, guys. Okay, you take Nokia, you take Sony, or you take any other company. Okay, this concept is applicable to all the companies and all their products, and that is what is going on today. What is happening? Everybody is going to a new data source. What is that new data source? That is your internet, guys. Internet is now today becoming the new database for the companies, where they want to write applications which will go to this internet, which will act as a database and get some useful insights and knowledge, guys. Okay, so I hope that is making sense, guys. We'll move on to the next slide here. Just give me 1 second here. Okay, sorry about the pause, guys. I'm back. Alright, so until now we have looked at what is Hadoop, guys. Okay, now what we'll try to do is we'll try to understand what is until now what we have looked at is we have tried to understand what is big data. So now, and how it is used and how it will be useful for companies. We have a few more real world scenarios that I will explain to you about the advantages and uses of it, guys. Okay, but before that we will try to understand what is Hadoop and how it is useful to us, guys. Okay, so here is what is Hadoop, guys. It's a open source. Hadoop is open source, which means it is free. It's under the Apache license. You have no restrictions. You can use it as you like and so on, guys. Okay, if it is free, it is much more useful for the companies, and it is much more easier for them to use, because if it's a commercial product, every company needs to go ahead and purchase a product. They need to convince their management and do all that lots of stuff before purchasing a product and getting the product into their company. Okay, many times companies will have free resources and things like that. Okay, what companies would like to do is they would like to take these resources and use them in some way or the other and if the products happen to be free or something like Hadoop, what they can do is they can develop custom products and custom solutions and play around with them and make a better utilization of their resources, guys. Okay, so that is what the advantage of the Hadoop being open source is. Okay, and then Hadoop provides us a framework of tools, guys. Okay, let's try to understand what Hadoop, what that means. Okay, at a fundamental level, guys, Hadoop is nothing but it's a distributed file system, guys. Okay, what is a distributed file system? Well, a distributed file system is a group of computers, guys. Okay, so imagine this is computer 1, imagine this is computer 2, computer 3, computer 4, and so on. Okay, so these are the group of computers which are acting as if they are one computer. What is that? Well, the cloud is one layer, one computer. It is sitting on top of this group of computers, guys. Okay, you can think HDFS as the brain of Hadoop, guys. Okay, why? Inside our brain, guys, we store different kinds of thoughts, right? So inside HDFS we store different kinds of data. The data could be binary data, textual data, JSON data, or any kinds of data. Different kinds of data is stored here in HDFS, guys. Okay, then imagine if this is the brain, we have something called a heart, guys. Okay, what is a heart? Heart, imagine we use our heart to analyze the thoughts in our brain. Okay, what does that mean? Well, in Hadoop you have another layer called MapReduce, guys. Okay, MapReduce is used for reading the data that you store in Hadoop, for processing the data that you store in Hadoop, and for analyzing the data that you store in Hadoop, guys. Okay, that's why MapReduce is called the heart of Hadoop, guys. Okay, and then we have a couple of eyes, guys. Okay, using our eyes, what do? Well, we go ahead and analyze the word, right? So similarly, Hadoop has one eye called Hive, guys. Okay, go ahead and type it here. What Hive will do is Hive will take simple SQL-like commands as input. Okay, it will convert them into Java MapReduce programs, and then they will get executed on HDFS, guys. That is what Hive will do. Hive is used for analyzing the data in a simple way. How? Well, you give the SQL as the input, guys. Okay. Similarly, Hadoop also has another eye. What is that? Well, that is what is called pig, guys. Okay. Pardon me. Sorry about that. So that is pig. And what will pig do? Well, pig will take simple English-like scripting statements as input, guys. Okay, so let me go ahead and come back here. Go here. It will take simple English-like scripting statements as input. It will convert them to Java MapReduce programs and analyze them and run them on HDFS, guys. Okay, so that is what pig is. Similarly, what is happening today in companies is many companies have different kinds of databases. So, they have an SQL server, they have a MySQL, they have Oracle server, and they have other next generation data warehouse solutions or databases and things like data warehouses rather, okay? Many times what they want to do is they want to go ahead and get the data from these databases into HDFS, and they also want to go ahead and get the data and put them back into these databases. What is that called? That is called importing and exporting the data. What do we have? Well, we have something called Scoop, guys, okay? So if I go here, Scoop is a tool which will take simple Linux-like commands as input, guys, okay? So go here. It will take simple Linux-like commands as input. It will internally convert them to Java MapReduce programs and transfer the data from HDFS to a database or from a database to HDFS. Transferring the data from HDFS to a database is called exporting the data, guys, okay? And transferring the data from a database to HDFS is called importing the data, guys, okay? So Scoop is a data transfer tool. And remember, guys, data in the database is called structured data. What is structured data? Well, if you have a table, we know there are parent-child relationship and things like that, right? So that is called the schema. If you know this schema of your data, then that is called structured data, guys, okay? But today, we have a new database. What is that? Well, that is the internet, guys. Remember our Samsung example? What did we do? Well, we got the data from the internet. What is that? Well, we get the data from Twitter, and then we want to save it in HDFS, okay? And then what do? We can write a few scripts in Hive, we can write a few scripts in Pig and understand and analyze the data and understand whether they're talking good, bad, or ugly about our products, about our company, and try to understand the problems of the customers, guys, okay? So what is the problem here? Getting the data from internet to the HDFS. What do we have? Well, that's where comes in Flume, guys, okay? So Flume allows us to transfer unstructured data. Scoop is allowing us to transfer structured data from databases to HDFS. Flume is allowing us to transfer the unstructured data from internet, from other sources such as internet or any other sources, any other servers and things like that, and save it to HDFS, guys, okay? So Flume is a data ingestion tool. It's like a data transfer tool of unstructured data, guys, okay? The data on the internet, the Twitter data, the Facebook data, you do not know what is the schema. You do not know what is the parent, child, and things like that. You just have some minimal structure. You may have some minimal structure, and that is the data we want to transfer using Flume, okay? So that is what Flume is used for, guys, okay? Apart from that, let's see what else we have. We have another tool called Oozie, guys, okay? Generally what happens in real world is we will not run each of these things one at a time. You will not run Hive, you will not develop Hive scripts, and you will not run one Hive script at one time. What you will do is you want to go ahead and first run some Hive scripts, then go ahead and take the output of that and give it to Pig. You want to do some processing, then you want to go ahead and take the output of Pig and give it to Scoop. Okay, what is that? Well, that's a workflow. Okay, Oozie is a tool which is used for scheduling these workflows. Okay, one after one. I want to take the output of this, give it to Pig as input, then the output of Pig as input to Scoop. Then I want to go ahead and save it on HDFS. Okay, so that is what Scoop does, guys. It will allow you to schedule these workflows to run periodically at various points of time. Okay, so these are the courses that we have in our content here. So if you go back here, and then we have Hbase, guys, okay? Another component of Hadoop is Hbase, guys. What is Hbase? Hbase is like a stomach of Hadoop, guys, okay? And the reason we call it a stomach of Hbase is if you want to modify the data in HDFS, it is not possible, guys, okay? What do? That's where Hbase comes in. Okay, if you notice here, Hive and Pig are used for analysis is one thing, guys, and they're sitting on top of MapReduce. Okay, Hbase sits directly on top of HDFS, guys. Okay, it does not need MapReduce. It will directly work with HDFS. It bypasses MapReduces and it directly works with Hbase. And this is not used for analysis, guys. Okay, this is used for modification of the data for your crude operations and things like that. And it is very, very faster. This kind of accessing database of Hadoop, guys. HDFS is not a database, guys. HDFS is a distributed file system, guys. Okay, and Hbase is the database of Hadoop. Okay, what is a distributed file system? A distributed file system is a group of computers. You see this one? These are a group of computers together. They act as if they're one computer, guys. Okay. Another way to look at it is, what we mean by that is, well, if you have a file which is saved in this computer and you try to access that file from this computer, guys, you will not be able to see that, right? But HDFS is something where if you have a file here, okay, which is sitting in this computer, which is copied to HDFS, and you log into this computer and try to read that file, you will be able to read that file, guys. Okay, let me see if I can simplify it like this. Imagine each computer as your ground floor apartment, guys. Okay, then imagine you have a first floor where you do not have any walls in the first floor. In the ground floor, everything is a separate ground floor apartment, but in the first floor you do not have any walls in there. Okay, so what is that? You have only one floor without any walls. So if you put a sofa here, you come into this ground floor apartment, go into this first floor, you will be able to look at that sofa from here to here. Okay, I hope that is making sense, guys. Okay, so one more time, HDFS is the brain, guys. Okay, we have one heart, that is our MapReduce. We have two eyes, one is Hive, one is Pig. Hive will take SQL as input, convert them to Java MapReduce programs. Pig will take simple English like scripting statements as input, convert them to Java MapReduce programs, guys. Okay, they're used for analysis, guys. Okay, and then we have Hbase. Hbase is the stomach of Hadoop, guys. It is a database of Hadoop. Okay, and it is used for modification of the data and performing any crude operations, just in case you're familiar with the SQL terms and things like that. Okay, so that is Hbase. Scoop is a tool for transferring structured data, which is data from different databases into HDFS and taking the data and putting it back into a database, guys. Similarly, Flume is used for transferring unstructured data, guys. Unstructured data from internet, from other servers and other data sources and things like that, and save it in HDFS. Once you save it in HDFS, we will use either Hive or Pig to go ahead and analyze the data and get some useful insights and things like that, guys. Okay, and then Oozie is a workflow scheduling tool. Okay, what will it do? Many times we want to run some scripts in Hive and give the output to Pig, and then we want to run some steps in Pig and give the output to Scoop, and so on. Oozie will allow us to schedule that kind of workflows running one after another at periodic points of time, guys. Okay, I hope I'm making sense, guys. So let's come back here. So what do we have? Well, that's the framework of tools, guys. One brain, two eyes, one heart, one stomach, and a couple of tools for transferring structured data into HDFS and unstructured data into HDFS, guys. That's the framework of tools. Okay, and what else we have? Well, that's the framework of tools we talked about. And then what is Hadoop, guys? Another way to look at Hadoop is helping us run applications on big data, guys. Okay, what is big data, guys? Just a few minutes back we discussed about the 3 V's: the volume, velocity, and the variety, guys. Okay, what happens is, here is what is happening, guys. Imagine this is your laptop, guys. Okay, and let's say you have about 1 GB of data. Okay, you can store it in laptop and you can do some computation on that. Okay, let's go ahead and perform some computation. It will give you some output, guys. Okay, that's not a problem. But let's say you have something like pardon me, 100 terabytes of data, guys. Okay, now what you do, you try to fit that on a single laptop or a single computer. It will not fit, right? So what do? What we will do is we will try to use multiple computers. Okay, so these we will try to imagine you have a bunch of computers, maybe 10, 20 or 100 nodes or servers or computers, and then what do? You need to split the data, right? So you'll put, few terabytes of data here, few terabytes of data there, a few more terabytes of data there and few more terabytes of data. So what are we doing? Well, how do you split the data? One problem. How do you split it so that it is correct? It does not give you a problem. So splitting is a problem, guys. Okay. Then what do? You need to distribute the data. How do you distribute the data correctly without any problems and without any other kinds of issues and things like that? And what does that mean? Well, that is the problem of distribution. Then what do you need to do? You need to write some programs. You need to run some programs on this data, which will go ahead and run on the data that you have distributed in various other computers. Okay, so what does that mean? Well, you need to know some concepts. What are those concepts? Well, you need to understand how the different nodes or computers communicate with each other. That is called multi-node communication, guys. Okay, then you also need to know what is called multi-process communication. Okay, you also need to be aware of what is called multi-threading and what is called networking, and what happens if one of the computer goes down, if your program is running. What is that? Well, fault tolerance, and how do you take care of that? You need to be an expert in all these things. What does that mean? Well, if you're a cricket player and you get into stadium, it's like before you do the batting and the bowling, right? You need to first clean your pitch, clean your stadium, clean your chairs, and then only you can do the batting and bowling. Okay, so if you're a developer, you're like a cricket player. What is the developer hired for? Well, he's hired for what is called writing the business logic or the analytical logic in an organization. Okay, so what will he do? Well, he will focus on, in order to write business logic, he needs to know multi-node communication, multi-process communication, multi-threading, networking, and other concepts. By the time he learns all these concepts, what will happen? The time will be over. And these complex are very complex, guys. And these concepts are very complex. Okay, it's not easy. Very few programmers in the world are capable of writing that kind of programs. Okay, so what will Hadoop do? Hadoop will give you a stadium where you don't have to worry about any of these concepts, guys. Okay, you can directly focus on the business logic and the analytical logic. Okay, so what does that mean? Well, if you're a cricketer, what will you do? You'll just focus on batting and bowling. What will Hadoop do? Hadoop will provide you the stadium. It will keep the it will take care of the pitch, it will take care of the chairs and the ground and so on. It is giving us the framework, guys. We don't need to focus on what is called operating system concepts or the framework level concepts. We focus on what is business logic and what is analytical logic that our company has hired us for. Okay, so that is how it is helping us running applications on big data, guys. Okay, what is happening? Big data, remember, guys, it's the 3 V's. When the 3 V's are growing, what is happening? The complexity of programming is growing. Okay, we have to learn a lot of concepts. We have to learn a lot of concepts for us to write programs on big data, and that becomes a very, very big problem, and you will not be able to focus on batting and bowling, guys. Okay, you'll have to first take care of your stadium to get to batting and bowling. Okay, so I hope I'm making sense, guys, and we'll move on to the next slide here. Okay, so let's try to understand what companies were doing before a framework like Hadoop has come forward, guys. Okay, Hadoop as a framework is simplifying these things, and it's providing an easy way to handle this kind of programs which are capable of running on multiple nodes, whether it's 10 nodes, 100 nodes, or 1000 nodes, guys. Okay, what were people doing? What they were doing was they would buy a powerful server or a powerful computer. Okay, so if they have lots of data, what they will do is they'll buy a very powerful server, add more nodes, add more RAM, add more processors, and things like that. They would make it more powerful. That is called vertical scaling, guys. Okay, that's a traditional approach. Okay, imagine, let's say you're in let's say you go to an Airtel office, guys. Okay, and let's say that guy is a PhD guy. Okay, and imagine, because he's a PhD guy, we need to pay him high salary. Okay, let's say we are paying him 1 lakh rupees per month. Okay, that's a good amount of salary, right? And what will happen? Well, what can he do? Well, imagine he is capable of processing. Well, what do we go to Airtel office? Let's say we go and pay our bills. And what is he doing? He's capable of collecting anywhere from 10 to 15 bills per hour. Okay. So what does that mean? Well, in a day, he's able to collect about 100 to 150 bills per hour if he goes ahead and works for 10 hours, right? What is happening? Well, we're paying about 1 lakh rupees. Okay. Now here is another scenario. Okay. Instead of one PhD guy, let's go ahead and hire 10 people who have completed their degree. Okay. That's person 1. That's a person 2. That's a person 3. Oops. And so on. Okay. Let's say, imagine that's our 10th guy. And since they have completed their degree, we can pay them a low salary. Okay. Let's imagine we're paying them somewhere about 10,000 rupees per month for each guy. Okay. And what's happening here? Instead of paying 1 lakh rupees for one guy, for 1 lakh rupees, I'm able to get 10 guys. Okay. And now what will happen, guys? Each person is also capable of collecting 10 to 15 bills per hour. Okay. And what does that mean? Well, whatever we're collecting, I think I should say this one as per day. Whatever we're collecting in one day, we are now able to collect in an hour. As a result of this, we will be able to collect all the 10 guys will be able to collect anywhere from 100 to 150 bills per hour rather than day. Okay, so what are we doing? What is happening here? For the same amount of money, we're able to get more bills collected. The more the bills that the Airtel office collects, the more the revenue they make, right? So how did we do that? At low cost. Okay, that is what is the difference between Hadoop and the traditional architectures, guys. Okay, what traditional architectures do? Traditional architectures use something called enterprise class servers, guys. Those are the powerful servers. You can add RAM, you can add a lot of hard drives and processors to that, but there is always a limit. You cannot go beyond a limit. Okay, if you come back to our example, right, even if you were to offer this guy 2 lakhs per month, okay, what will you do? His capacity will still remain the same. There is a limit on how much this guy can process. He's like our enterprise class server. And instead of enterprise class server, right, instead of paying 2 lakhs rupees per month for this guy, if I go ahead and get 10 more people who have completed their degree, what is happening? Our processing power is increasing. Our computation time is decreasing, and we're able to do more amount of work in a short period of time, guys. Okay, I hope that is I'm making sense, guys. Okay, so that is the traditional architecture. Short and sweet. In traditional architectures, what they would do is they will go ahead and use powerful enterprise class servers, but they can process only limited amount of data, but they have a limit on which the amount of data that they can process. They can also purchase multiple enterprise class servers, guys, but what will happen? Well, your complexity of the code will increase, guys. It is not easy for them to go ahead and process all the data. Okay, what does Hadoop do? Hadoop will go ahead and, if you have big data, what it will do is it will split your data into multiple pieces, guys. Okay, so to understand that one, let's go ahead and take a quick look at this example. Imagine you have a file. This is your group of computers, guys. Okay, computer 1, 2, 3, 4, and so on. Imagine you got a bunch of computers, guys. For the sake of simplicity, let's imagine we have a file which is 100 megabytes. Okay, say this is 100 megabytes file. Okay, now what do we want to do? Well, we want to go ahead and save this file into Hadoop. Okay, what Hadoop will do is, here is what Hadoop will do, guys. Hadoop will first split this file. It will split the file into 2 blocks, each one in the order of 64 MB. Okay, So let's go and use that one. That will be 64 MB and that will be 36 MB. Okay, so let's go and put this here. That is 64 MB and this is 36 megabytes. Okay, this is called the process of splitting the data, guys. Who will do it? Hadoop will do it. Okay, you will not do it. Then what will Hadoop do? Hadoop will take this one, this 64, it will call each split as a block and it will save it here. Okay, so that is saved there. Next, it will come back here. You will take this 36 MB and save it on another node. Okay, let's assume it's saving it here. Come back here. So there's the 36 MB which is saved, guys. Okay, what is this called? This is distribution, guys. What is happening here? Well, the process of splitting and distributing the data is happening, guys. Okay, what does that mean? Well, it is taking care of the multi-node communication here, guys. Multi-node, multi-process and all those complex things that we have talked about. We do not have to be an expert in that, okay? So that is, it will take care of the splitting and distribution. Then what will it do? Well, it will go ahead and replicate the data, guys, okay? What does replication mean? Well, whatever block of data it saved on node 1, it will make a copy of backup of it there, backup of it there. Similarly, it will maintain a backup of the 36 MB there and 36 MB there. Why? Well, one of the reasons why it does is because Hadoop works on what is called commodity hardware, guys. Okay, remember our PhD guy versus degree, guys. Traditional architectures use enterprise class servers, guys. Enterprise class servers are very expensive. Okay, just like our PhD guy takes 1 lakh rupees per month, you know, and the enterprise class servers are pretty expensive is what the deal is. And one of the things, the reasons they're expensive is because the manufacturer gives you the guarantee and the reliability on the reliability. He says, I'm giving you 99.9% uptime and reliability on this server as guarantee. Okay, Hadoop on the other hand works on what is called commodity hardware. It also works on enterprise class hardware, but enterprise class servers is not a must here. You can use something called commodity hardware. Commodity hardware is like cheap hardware, or rather inexpensive hardware compared to the enterprise class servers, guys. Okay, commodity hardware is in the range of $5,000, whereas enterprise class hardware is in the range of $20,000 to $100,000 to, you know, and so on. So that's so Hadoop works on commodity hardware. One of the problem with the commodity hardware is they can fail anytime. Okay, if they fail, what will happen? The data on this one will be lost. Okay, but what did we do? Hadoop goes ahead and replicates the data. So it replicates the data. So any data which is there is also available here, is also available here and here. So it has a backup of the data. Okay, so like that, what Hadoop is doing is, this process is called fault tolerance, guys. Okay, so that is provided by Hadoop. And again, we are not writing any of this code, guys. All this is being taken care of by the engine of the Hadoop. If you want to drive a car, what do? You turn the key. You don't have to be a mechanical engineer to drive a car. Similarly, if you want to work on big data, what do? Use simple tools such as Hive and Pig. You don't have to be a master of multi-node communication, process communication, threading and all the networking concepts and other concepts, guys. Okay, so that is how Hadoop works, guys. It takes care of all these things internally. So what is Hadoop doing? Well, step one, it goes ahead and, let's say this is our file. Let's say this is our resume, guys. Okay, what it has done is, imagine our resume is getting split into 4 blocks. Okay, what does it do? Well, it will save each block on one node. And all these are commodity hardware. So instead of using one PhD guy, I'm using 10 degree guys who are much cheaper in cost, right? Then what will happen? Well, at any point of time, these servers can go down. Why? Because they're commodity hardware. The commodity hardware means they're inexpensive. Why? Because they do not guarantee the reliability and the uptime. That is the difference between the enterprise class server and the commodity hardware, guys. Okay, so what happens as a result of that? We might lose the data. So what does Hadoop do? Hadoop will replicate the data. Every page, assuming this is our resume, if I call my page 1 as block 1, my block 1 is also saved here, my page 1 is also saved here, guys. Okay, at any point of time, if one of the node goes down, I still have backup of my data available in other nodes, right? What is that? We are protecting the data. That is called the fault tolerance, guys. Okay, and what is the magic? What is the important thing here? All these things are being taken care of by the Hadoop. What do? We just do the batting and the bowling. What is batting and bowling? That is, you focus on the business logic. You focus on the analytical logic. If you want to drive a car, you do not worry about how your fuel is getting converted to electricity. Okay, you just turn the key and the car drives. Okay, so what is our key? It's our hive, it's our pig, it's our scoop, our flume, our Uzi, and other things, guys. Okay, and one other important thing about Hadoop, guys, okay? Hadoop allows us to write what is called scale-free programs. What is a scale-free program? Well, let's say I write a program which works on a, let's say I have a laptop, guys, okay? That's my laptop, and I have written a program. This program will go ahead and perform some computation here, okay? Now it works successfully here. Now what do I want to do? Well, what I want to do is I want to take this program, deploy it on a 100 node cluster or a 1000 node cluster. Okay, ladies and gentlemen, we will not make a single code change. Hadoop will take care of that, okay? So you do not have to make a single code change. Hadoop will automatically make sure that your program will work on a 100 node or 1000 node cluster without even a single code change. What is that? That is what is meant by scale-free programs, guys. Okay, I hope I'm making sense, guys. So feel free to let me know if you have any questions. In the meantime, I will try to proceed. Okay, guys. So until now, that is what is Hadoop, guys. Okay, until now, what I have explained, what I have tried to explain is what is big data and what is Hadoop, guys. Okay, next few minutes I will show you a couple of use cases where how Hadoop is used in the real world, guys. Okay, so let me go back here, snap of that. Okay, so gentlemen, ladies, here is what is going on, guys. Okay, Los Angeles, California, Los Angeles Police Department, California, somewhere in California, what they're doing is they're using something called Predictive Analytics, guys. What is Predictive Analytics? Well, what they do is the police department takes their 10 to 15 years of data set. Okay, they will take 10 to 15 years of crime data set, and then they will every day night they run a few map reduce programs and they will analyze this 10 to 15 years of crime data set. What is a crime data set? Well, anytime you get a call from a robbery or about a burglary or anything, right? What they will do is they will first go ahead and send out the police or the cops, and then they will go ahead and make an entry of the data that they have with them. Okay, that data over a period of 10 to 15 years is very, very huge, and that is what we mean by the crime data set, guys. Okay, what do? Every day night they run a few map reduce programs. They analyze this data. Then what do they do? Well, they predict. What do they predict? Well, here's what they predict, guys. This is spot number 1 where the crime is likely going to occur. This is spot number 2 where the crime is likely going to occur, the second probability, and this is the third probability where the crime is likely going to occur. Okay, on the following day morning, what will happen is when top police officials come, what they do is they look at this data, they use their own experience with a combination of both of them. What do? Well, they make a decision. They'll say, let's go ahead and deploy 25% of our police force here. Then they will say, let's deploy about 15% of our police force here, and let's deploy about 5% of our police force here and scatter the rest of them throughout the city. What does that mean? What will happen as a result of that? Will the crime really reduce? Well, we cannot say. They cannot guarantee. But it seems the statistics have shown them that the crime numbers have come down. Is it necessarily because of this? We cannot say. But it seems it has helped it, guys. There's a lot of psychological evidence and proof that it has helped, and we will not go into those details, but that is how they are using, guys. Okay, now If that is making sense, guys, okay? Let's say you're living in Hyderabad, guys, okay? Imagine the same concept we are using in somewhere in the police station of Hyderabad. Do you think we can use it, guys? Take a moment. I'm going to give you a countdown of 5, 4. Okay, gentlemen, I don't know if you have given a thought. Gentlemen, ladies, we can use the same concept anywhere in the world. What does that mean? Well, big data solutions are globally applicable. If you come up with a decent solution, if you come up with a solution which is applicable in one scenario, you can see you can apply the same scenario throughout the world in many other places. Now you understand why everybody is after big data. So that is one of the reasons, guys. Okay, if you're working on a Java or a .NET programming, Java or .NET shop or a company, right? You're specifically writing programs for that particular company. But in a big data world, when you write the programs, they become globally. You see a global applicability of the programs, guys, okay? So that is one advantage. I don't want to over exaggerate about it, but that is a good possibility, guys. That is one of the reasons why companies are very interested in big data, okay? Next, we'll look at in telecommunications, how big data and Hadoop is used, guys, okay? I hope it is making sense, guys. Okay, sorry about the pause, guys. So let's see. So here is what is going on in telecommunications field, guys, okay? Today, nobody is using landlines. As a result of that, the voice calls are going down, the calls are going down. And what's happening? Today, every day there's one new cell phone coming up and they're offering much lower prices. Okay, so as a result of that, the prices of the telecommunication company that they can charge are going down. And what's happening? Well, the competition is growing every day. And a telecommunication company has a lot of infrastructure around the world. What does that mean? Well, their costs are increasing day by day. These are some of the problems of a telecommunication company, guys. Okay, so what happens? Let's see how big data and Hadoop comes to their rescue, guys. Okay, imagine. So one day there is a coffee shop which is getting opened. Okay, and imagine this is a coffee shop. Imagine this is a laundry shop, and imagine this is a movie theater, guys. Okay, so what is happening? These coffee shop people come to the telecommunications company and say, "Hey, guys, we keep hearing about this big data. Okay, we want you to help us in using this big data," is what they ask them. Okay, so what does telecommunications company do? They do some R&D. They come up with a plan to help the coffee shop. Okay, what do? Well, they come up with a plan. Their plan is they are going to target all the coffee drinkers around the city. Plan A. Okay, and plan B. If the coffee shop is around the location of the coffee shop, yes, there are a lot of people moving around the coffee shop, right? If somehow we can bring these guys into the coffee shop, what will happen? Well, they can increase the sales of the coffee shop. That is the set plan B. Plan C. Social influencers, guys. Social influencers means those people who are popular, guys. Your Hollywoods, Bollywoods, and Tollywoods, and so on. These guys, if they, at maybe 80 or 85 years of age, why do you think Amitabh goes and writes some blogs and tweets about some companies saying that something is good, something is bad? Well, because he's getting paid. Companies, they hook up with these top popular guys and they say, you keep talking about my company on your blog or tweet and I'll pay you some money every time you talk about it. Okay, behind the scenes. Okay, so what do? Well, they have to, the plan C of this telecommunications companies, they will try to figure out the social influencers in that city. How they will use, we'll see. Okay, that is plan C. Plan D, the movie theater next to the coffee shop, guys. It's just next to the coffee shop. Lots of people are going to the movies in the movie theater. If somehow we can bring some of them into the coffee shop, we can increase the sales. Okay, what is that? Well, that is the plan D. Okay, that is the plan they come up with, guys. So what do? Let's see. What they do? Sorry about the pause, guys. Okay, just clearing my throat there. Okay, so here is what they do the next day, guys. The telecommunication company, sorry about the pause, guys. So coming back, the telecommunications company go ahead and download all the data from LinkedIn, Facebook, Twitter, Google Plus, and they try to analyze this data. What do they find? Well, they find there's a guy called Jim. He's a social influencer, okay? And he's also a customer of this telecommunications company. What do? Well, they analyze his mobility patterns. What is he doing? Well, they look at his cell phone log files. Every time we move from one location to another location, guys, what is happening is our cell phone is transmitting our latitude and longitude position. All the data gets logged into your log files in the cell towers, in the nearby cell towers. What does the company do? They get all this data into a central place. They analyze that data. What do they find? Well, this guy Jim at 8:10, he's starting at home. At 8:25, he's stopping at a coffee shop. Okay, he's going to work at 3:05. He's coming out and having another coffee at another coffee shop, and then at 5:30 he's starting at work, and at 7 p.m. he's going to the movie theater. What are these things called? These things are called mobility patterns, guys. You can analyze your log files and you can understand these patterns. You can get these patterns, okay? So what does that mean? Well, he's drinking coffee twice a day. What does that mean? Well, he's a coffee drinker. He's also passing by the coffee shop location. How do you know that? Well, again, the moment, every time your latitude and longitude changes, your cell phone is transmitting that data to your cell towers, right? So by analyzing those log files, you can find out what are the locations he's present in, and they detect that he's in the nearby locations of the coffee shop. Okay. Next, he's a social influencer. What does that mean and how do they know? Well, they downloaded all the data from the internet, his Facebook, Google, and other things like that, that is publicly visible. Okay, and they analyze. What do they notice? They observe that there's a lot of activities generating. If he writes a blog, if he writes a tweet, he has a lot of data which is getting, he has a lot of activity that he's generating on his site. So what does that mean? Well, anything he writes, his message is reaching many people. What does that mean? He's a social influencer, guys, okay? And he's going to the movie theater next to the coffee shop. Okay, so what does that mean? Well, that means he's also a moviegoer. What does that mean? Well, he meets all the requirements. So what happens? The next day, he gets a message from the coffee shop saying that you can get a free coffee. Okay, so imagine if we were to get a free coffee, what would we do as well? A decent coffee shop, I will not only go by myself, but I generally go ahead and take 10 or 15 or maybe 5 to 10 of my friends and go there just as a expression of gratitude, right? We go there, we have the coffee. Okay, so what does Jim do? Jim will have the coffee because he's a coffee drinker, and then he comes out, opens his laptop, and he writes a tweet saying that, hey, I love that coffee. Okay, if you notice that, guys, what is happening here is the coffee shop has not spent a rupee or a dollar on a TV ad or a movie ad. What is happening? Just one single coffee offered to one customer, what is he doing? Well, he's going ahead and spreading the word. Okay, if you see something very important on the screen, guys, just one free coffee, the message is capable of reaching so many people. He has that many followers. Okay, imagine how many social influencers could be there who will maybe retweet this one, and how many followers each of those will have. Okay, if you understand that, that's a lot of people, guys. Okay, that is the new way of marketing. That is how the modern day marketing is increasing. Every company today, in every company, this is the scenario they're trying to, this is the big data scenario that they want to incorporate into their existing architectures and designs. Okay, so without wasting much money, they're able to spread their word about their coffee shop. What does that mean? More the people know, more the probability of the people coming into their coffee shop. More the probability, more the sales. More the sales, more the revenue. I hope that is making sense, guys. Okay, so that's about the coffee shop. What do people do? Well, people will come back and say, I love that coffee. What does that mean? It seems in a recent survey, 69% of the people who say that they like it, they really mean it, it seems, guys. What does that mean? Well, more people come to know about your coffee shop. More people come to know, more the sales. More the sales, more the revenue. Okay? Now, okay, so that's the important thing, guys. So now imagine if we were to take this concept and we were to go to a nearby coffee shop in our area, do you think we can use it or not? I will leave that question to you guys, okay? If you really need the answer, feel free to, let me know. But just think about it. That's some food for thought, guys, okay? If you will. Okay, guys, so here is the final project that we'll be looking at. So in the interest of the time, I will go ahead and explain. We'll continue with this one. So just give me 1 second here. Okay, here we go. Okay, guys, so let me come back here. All right. So this is the final project that we will be working on, guys. Okay. Before I talk about a little bit about the final project, after this project is over, we're also going to be covering a little bit of Spark, guys. I did not explain Spark earlier when I was explaining about the eyes, the brain, the heart of Hadoop and things like that. But Spark is also another important component that we're going to be covering as part of our course, guys. Okay. So let's try to see what is the problem that in the banking scenario, guys. What we have is we have one of the world's largest financial institutions in North America, and what's happening is the client has implemented small business banking e-statements project using existing software tools and applications. So using traditional architectures, they have some e-statement project which has been implemented. And what's the problem they're facing is their overall process to generate these statements and send alerts to customers is taking 18 to 30 hours per cycle day. Okay, so every day or periodically they will generate a lot of e-statements and alerts. What's happening? 18 to 30 hours. Why? Lots of data. Okay, remember the volume. Okay, and on a daily basis they have lots of data coming in different varieties. Okay, we'll see that in a second. But the problem is 18 to 13 hours of time is what it is taking as. What's happening? Well, they're missing their SLAs, the service level agreements. Customers are not happy about that. Okay, what do they want to do? Well, they want to cut down their processing time to generate these statements and alerts. Okay, by at least 50%. How do they want to do? At a low cost, without really putting in a lot of money, wasting in a lot of money, without really being sure if they will be really able to solve the problem or not. Okay, so that is the problem statement, guys. Okay, so here is a architecture, existing architecture of how things work in the banking as of today. They have different kinds of applications which are sending their data to a central application from which they generate this e-statements and alerts, guys. So this is their central application where they have a bunch of upstream applications. All the upstream applications are sending their data here. Once the data comes in here, they're doing more processing and generating the alerts and sending it to other applications and so on. What will we do? Well, we will go ahead and introduce Hadoop here. Okay. We will introduce Hadoop here, and now what will happen is all the upstream applications will start sending the data to Hadoop. So from a few databases we'll use Scoop and we'll get the data. From a few applications we'll get the unstructured data using Pig, and there are a few other files which we will use Hive to get the data. Okay, so here is what we have, guys. Okay, before we move on to solution. Okay, so using Pig, we're going to get all the unstructured data and we'll save it in Hadoop in HDFS. Using Hive, we'll go ahead and get some files using Hive, and then we'll go to different databases, use Scoop, okay, to get the data and dump it in HDFS, okay, and then Hive again. And then what we will do is we'll go ahead and write a few scripts in Pig and Hive, which will get us the final output. Okay, so that is what the high level workflow looks like, and as a result of that, this is what we achieve, guys. Okay, the overall process reduced to 10 minutes to 1 hour. The overall cost reduced by 50% due to the elimination of the mainframes and due to the elimination of the mainframes, guys. Okay, that is what they have accomplished in this one, guys. Okay, so this is the low level design, and that is going to be the final project, guys. Apart from that, we will also look up take up a project in Hive and Pig where we will involve in de-identification of the personal health information. So we have a lot of sensitive data that is sitting in HDFS that we will use Pig and Hive to. We will see in Pig and Hive how to de-identify this data, okay? And we'll talk a little bit more that will give you a good perspective of how the things work in Pig and Hive. Another project that we will also take up is the Flume, where we'll try to understand how to handle the big data and the JSON data, and how things actually work in real world. For example, in Twitter and things like that. Okay, so what do we have? We have lots of tweets coming into Twitter. We'll go ahead and use Flume. Flume will act as a bridge, which will allow us to get all the tweets into HDFS. Once the tweets are there in HDFS, we'll go ahead and write a few scripts in. We'll create a few tables and write a few scripts in Hive, which will allow us to analyze that data, guys. Okay, that is what the final project is. Okay, so that is about this course, guys, and that's about big data, guys. I hope that makes sense. That was making sense. So it's about big data is helping the companies in becoming smarter, guys. Okay, so what is it that the big data is providing and helping us? Well, big data is a problem. Hadoop is a solution. With that solution, you can become smarter. Okay, as we become smarter, we can contribute more to our organizations and companies. That is what the big data is about, guys. Okay, and as you move on, just a little bit of insights into different companies and domains where big data is used heavily. Almost every company, guys, today they want to go from a reactive mode to predictive mode. They don't want to wait for a problem to occur. They want to predict if a problem is going to occur or not, and they want to be ready proactively. Okay, that's why it's capable of applying in almost every industry and domain, guys. Okay, it's not that it's only used in certain industry or certain domain. If you look at marketing, these are the different scenarios. I will not read out these scenarios, guys, but that is just to give you an idea of the different scenarios where it can be used. Similarly, sales, customer service, and manufacturing, and different locations around the world where Hadoop is used heavily. So that's about the big data, guys. And moving back, and I hope that was of help to you. So coming back here, this is the plan. Week 1 again will focus on big data and Hadoop, and week 2 will focus on map reduce and planning of the Hadoop and Hadoop 2.0, and week 3 will focus on Pig and Hive. Week 4 will focus on Hbase and Scoop. Week 5 will focus on Flume, Uzi, and the final project, guys. Okay, and then as an additional complement, we'll also cover Spark and Scala in week 6, which is going to be our last week, and detailed view of what are all the internal things that we are providing is also given here, guys. Okay, I hope this is of help to you, guys. Please feel free to get back to us and let me know if you have any additional questions. We will also try to, the LMS also allows you to go ahead and have a look at the previous sessions. So every session that we are going to be taking will be recorded and will be made available via the LMS. So it will be your, I think it is provided for lifetime, so access. So please have a look at it. We will also try to answer any additional questions that you may have. You can send us an email, guys. Okay, with that, I will wrap up for today, and we'll meet tomorrow again we'll go with the first session. Some of the concepts I will again refresh one more time, guys. So it's a quick summary. We've looked at what is big data. We tried to understand what is Hadoop, why big data and Hadoop is important, how they are used in real world, and we looked at a sample project that we would be doing towards the end, and how it solves the problem. So what you guys can do is you guys can take the similar concepts to your own work in your own company and see if you can apply them in your own company and be of help and be of contribution to your company, guys. Okay. So that is the final message. With that, I will wrap up, guys, and I look forward to meeting you again. And so I wish you guys all the best and good luck. And big data is growing. If not today, tomorrow your company is going to touch it, guys. So Hadoop is a wonderful blessing for us. So I would strongly recommend you try to learn that. And with that, wishing you good luck. I will sign off here, guys. Okay. Thank you for now. Bye.